Hello everyone, I'm Inam. I'm thrilled to welcome you all to this fascinating video lecture on steel structure. In this particular video lecture, we will be solving a question related to staggered holes. In last lecture, we discussed the introductory part of staggered fastener. In this particular video lecture, we will be solving a question related to a staggered fastener. In this lecture, we will be computing the net area for staggered fastener, and in this question, we will be understanding the whole concept of staggered fastener and how it yields the minimum area. As we discussed in last lecture, the introductory part, that the staggered fastener provide the minimum area, and the better option is to provide the holes in a single row. So if it is not possible, then we will be providing the holes in a staggered pattern. So here you can see that different holes that are in a staggered pattern. You can see that different dimensions here in this question, and the tensile load is applied here. From this you know that it is a tension member, and here the distance parallel to the center to center of the holes, and this distance is parallel to the applied force, tensile force, and this distance is 3 inches between the two holes, center to center distance, and this distance is said to be the staggered length, and the perpendicular distance as per the question here is the from this center to this center of the holes, and this which is the perpendicular to this force. This length is said to be the gauge length, which is 5 inches, and you can see that the one path is here A B C D E, and one is straight part of the failure path. So we will be computing the net area for this. So I am considering two cases. The number one is that if the failure is straight failure, means that if the failure path is this A B directly D E, and one of the possibility is that the failure path is the staggered pattern, means A B C D E, means this is the staggered failure. So we will be discussing about this failure in this particular video lecture. So in this, moving toward the solution for this question, we will be computing the net area for this question. Here you can see that the thickness of the plate, which is 3 by 4 inches, and the gross width, which is considered this distance from this point to this point, distance is 3 plus 5 inches plus 5 inches plus 3 inches, which comes out 16 inches is the gross width. Now we will be calculating the gross area, which is the very first step to calculating the net area. For this we need the gross width and the thickness of the plate. So after multiplying the gross width with the thickness, we will get the gross area for this plate is 12 inch square. Now we have different dimensions for this which will be applied for staggered fastener, and one additional factor will be used in while discussing the staggered fastener. So this additional factor consists of different dimensions which are the from different distances, means this center distance from this center distance of the hole to adjacent hole, this distance is parallel to the applied force, and that distance is termed as the staggered length, which is 3 inches for this question. Remember this is the parallel distance between for this applied force. So it is 3 inches, and gauge length for this is 5 inches, as I discussed earlier that this is the center to center distance between two holes, and it is the perpendicular to the applied force. This distance is perpendicular to the applied force, and this distance is termed as the gauge length. Now the one is the diameter of the hole which is 1 inches. Remember this, the diameter of this hole is 1 inch, and these distances will be used in calculation of a factor which is additional factor, which will come in while discussing the staggered fastener. Now we will be solving a different failure path. There are two possibility for failure path. The number one is A, B, C, D, E. A, B, C, D, E. If this if this connection, if this plate element is failed in this section, so this will be the failure path A, B, C, D. In this failure path, we have this nice formula, because here you can see that this is inclined, means I am considering the staggered failure. For this we have a nice formula, that is the net area for this will be equal to the gross area minus the area of holes plus additional factor, which is the summation of S square divided by 4G. This factor will be used. Remember this in terms of discussing the staggered fastener. So what is the net gross area? We discussed in last slide, which is 12 inch square, and the area of holes, how many holes occurs in failure path? There are total number 3 holes occur in the failure path, and you can see that the gross area is this. Number 3 holes occur in the failure path, and the thickness of the each hole of the element of the plate is 3 by 4 inch, and the diameter plus the tolerance is 1 plus 1 by 8 inches plus, and this summation denotes that how many inclined paths. There are 2 inclined paths, so instead of summation we will be using 2 into S was this 3 inch, 3 square divided by 4 into what is G here? G is 5 inches multiplied by thickness. So after doing calculation, we will get the net area for this section is 10.1438 inch square. Remember this is the net area in case of staggered failure. If I am considering the failure in this path, so what will be the failure path? If I am considering the failure is straight without considering the staggered failure, I am considering the straight failure through this path A, B, D, E. So if I am considering this path, so the failure will be, the net area calculation will be as easy. We will be eliminating this factor. This factor comes while discussing the staggered fastener only, staggered path only. So I am only considering the straight path without considering the staggered path. So I am eliminating this factor. Remember this. So after putting the gross area and the total number of holes occur in this path are 2. So I am putting the value of number of holes 2 and thickness and the diameter of the bolt with the tolerance, and 12 is the gross area plus, and this you can see that the red numbers which is 0 means how many inclined lines here? None of the inclined lines here, so I am putting, instead of summation is 0 and this factor. So after calculation the net area will be 10.3125 inch square. So I get 2 net areas. Remember this. The number 1 is for staggered failure, and second is for the straight failure. So which net area should I use for design? So it is very important to decide this. So if you know the concept, you can easily pick which area should I use. I have 2 cases. Number 1 is in case of staggered holes. In case of unstaggered holes means if I am considering a straight failure. In this section I am considering a staggered failure. So for both, the net area for the staggered is 10.183814 inch square. For straight failure the net area is 10.3125. So you will be selecting the minimum net area. Remember this. For design, we need the minimum value to achieve a safe side value, to design a member in the safe side. So we will be selecting the minimum area, the one failure path who yields the minimum net area. So we will be using this in calculation. Remember, this is the very crucial, very important topic. It depends on the concept that what you grasp in concept. So this is the main point of this video lecture. So here the net area will be the minimum one. So I'm using the this net area in calculation. So I hope you got it. You understand how to solve the net area for the staggered fastener if the holes are provided in a staggered pattern. So there will be a nice calculation I discussed in this lecture. I hope you got it, and this net area will be used in further design calculation in limit state of fracture in designing of a tension member. So thanks for watching.